So we just discovered in the last example that the period is equal to 2 pi over omega. So in this example, it says given that t, the period, is equal to 2 pi over omega and frequency is defined as f is equal to 1 over the period t, how do omega and f relate? Well, since f is equal to 1 over t, I'll write that down first here. I'm going to do this one carefully, right? It sounds like I should. It sounds like a math derivation. I think it's clear that if this is true, that means the period is equal to 1 over the frequency. And then combine that with the result that we're given here that was from the last example. That implies that 1 over f is equal to 2 pi over omega. And then if I cross multiply from there, that is algebraically equivalent to omega is equal to 2 pi f. And even though that's not the best looking omega I've ever drawn right there, this was the formula that we presented on the key concepts page, and I suggested you can easily remember if you're ever stuck for what was that formula with the 2 pi again, and where do I put the 2 pi, is I would suggest thinking about f as being either maybe revolutions per time or per second, or maybe cycles per time or per second, and then omega is thought of as being radians per time, and since there's 2 pi radians per cycle or revolution, that dimensionally makes sense. But what we've actually done here is between the last example and this one, starting from a function that we've agreed is representing simple harmonic motion, we've actually been able to derive this based on well-founded mathematical definitions.